Hey, what's going on guys, Tanmay here. Welcome back to another video tutorial on data structures and algorithms. And today we are starting off with a very important topic in data structures, and that is hashing and what is a hash table. So this is an entire subtopic under the data structure subject, and there are many topics under hashing itself. So this is just an introductory video to hashing, and we're going to understand what is hashing, why do we need it, and what is a hash table. Okay, so these are the three questions primarily that we're going to answer in this video. As I said, this is just an introductory video, this is a theoretical video, but we will understand what is hashing and more importantly why do we need it, because this is a very important question to be answered. And we'll also take an introductory look at what is a hash table, which is a data structure. Now just like any other data structure like an array data structure or linked list or a tree or a graph, hash table is also a data structure and it has its own pros and cons. So we'll discuss them in this video. Now before proceeding, I hope you know what is a data structure. I hope you've followed this DSA playlist. If not, please check out this DSA playlist. We have a lot of other topics covered in this DSA course, in this DSA playlist. And with that being said, let's start off with understanding what is hashing. Alright, so the first question, what is hashing? By the way, you guys can take a screenshot of this notes if you are preparing theoretical answers for your exams. You can make a complete answer from this entire screen over here, from all this data which I have compiled from different resources. It's a perfect theory answer. If you want to take notes, as I said, you can take a screenshot or take it down. Alright, so what is hashing? Now in simple terms or in technical terms, let's first just read out the definition. Okay, so hashing is the process of converting a given input. Generally it is arbitrary size, so generally it can be anything, it can be text, number, and the size can vary, and it converts this input key into output value, which is generally a fixed size. Okay, so this is the very basic definition of hashing. Once again, I'll just simply read it out. Hashing is the process of converting a given input key, which is generally arbitrary in size or random in size, basically not fixed, into a output value which is generally a fixed size. Okay, so how is this done? This is done via a hash function. Okay, plain and simple, very simple to understand this one line. But obviously the second question that we should get immediately after understanding what is hashing is, why do we need it, right? Why is hashing needed? So we'll understand this in this video as we proceed, but let's first understand what is this hash function. So this hashing thing is carried out via a hash function. Let's take a look at what is a hash function. So a hash function is any function that can be used to map data of arbitrary size to a fixed size value. Again, this is just the same statement which is framed differently, basically taking a input data of arbitrary size and converting it to fixed size value. So this hash function generates new values according to a mathematical hash algorithm, and this algorithm can be anything. Okay, so there are many different hashing algorithms, and depending upon that we take a certain input and we generate a certain output. Okay, makes sense? Now to just explain this diagrammatically, just come to this right side and let's see the hashing process via a diagram. Okay, so if you observe, we have key 1, key 2, key 3, all of them go towards this hash function, and this hash function generates a particular index where the value is stored. Okay, so basically it maps a key to an index in this table which is called as a hash table where you find its value. Okay, alright, coming back to theory, we'll again come to this table in a minute, but let's quickly understand some terms. So the value which is returned by a hash function are called hash values, hash codes, digest, or simply hashes. Okay, so basically when you are gonna create a hash of, let's say, a value that I pass ABC, the output that you get, let's say the output you got is XYZ. This XYZ is generally termed as hash or hash value or hash code or digest. Okay, this is just for example. The output that you get is basically called a hash value. Alright, okay, let's move ahead. So now that you've understood the basic of hashing and what is a hash function, as I said, the bigger question or the main question is, why do you need it? Okay, so to answer this question, why do we need hashing, there is one important word which is called efficiency. Basically the time complexity of storing data in a hash table is generally O of 1, which is basically constant time. Similarly, the time complexity to even access that data, basically inserting, updating or deleting, is also constant time. Now this unique feature of hash tables is what makes it more efficient compared to other data structures. Now do note that this is not always exactly constant time, and a hash table is not a perfect data structure when you are dealing with large number of values because of the issue called as collision, and we'll talk about that in a minute. But just understand that for a perfect hash table or for an ideal hash table, which is theoretical and not practical or not in the real world, time complexity for storing and accessing data is generally happening in constant time, which means that it is very fast. How does this happen? I will demonstrate in a minute. We'll take an example of array versus hash table. But before that, let's complete a little bit of theory before you take the practical example. Now talking about the components of hashing. So basically there are three major components. One is the key, or you can also say the input. In the diagram over here, you can see this is the key on the left hand side. The second component is the hash function. So the hash function receives this input key and returns the index of an element in an array called hash table. So when you pass this key k1 into this hash function will return the index. So if you follow this yellow arrow for key 1, you will go to this index 2 over here, right? So this index 2 is returned when you pass key k1 inside this hash function. And what is this 2? It is basically the index to a value which is corresponding to key k1. Okay, so key 1 corresponds to value 1, but it is not stored at index position 0. You can see this. So in the hash table, this index value is calculated using this hash function. Of course, this hash function can be anything. The mathematical algorithm used over here right now is not seen over here, but you can use any kind of algorithms, and we have many other inbuilt hash functions and hash algorithms already. Okay, we'll discuss them as we proceed, but just understand that the function that calculates this index value depends completely upon the user who's writing this hash function. Okay, so that is the component hash function. And lastly is the hash table, which is this entire table over here. And hash table is a data structure that maps keys. So it maps these keys to values using a special function called hash function, which is this one. And each data value has its own unique index. So key k1 will always go in this index. Key k2, if you follow the red arrow, will only go into this place. And key k3, if you follow the blue arrow, will only go in the 0th index. You may notice that index 1 is empty. So that can be filled. Let's say if there is one more key 4, if you pass that, this hash function may place it, depending upon what algorithm is used, it may place it over here and call it value 4. Okay, so each key has a unique index location in the hash table. Okay, so this is what basically the hash table does. It maps the keys to values using a special function, and each data value has its own unique index. So no other key will be placed over here once this key k1 has occupied this place. Alright, okay. So applications of hashing. Well, applications of hashing would be one, when it comes to data structures. In context with data structures and algorithms, the biggest application is data storage and retrieval. So most popular use of hashing is the implementation of hash tables. So hash table, as I said, is a data structure which maps keys to unique indexes where the value is stored, right? So that's the most popular use for hashing. So hash table stores keys and value pairs in a list that is accessible through its index. And when it comes to hashing in context to cryptography and network security and cyber security, hashing is also used for encryption and decryption purposes, and there are many pre-written algorithms. You must have heard SHA-1, SHA-2, MD4, MD5 hashes. These are one-way hashing functions, and if you have a subject of network security or cryptography, you definitely must have heard about hashing. In fact, we do have a network security playlist on this channel where we have discussed some of this, so you guys can check it out. Okay, so this was the whole theory around what is hashing, why do we need it, and what is a hash table. Now out of these questions, I think what is hashing is pretty clear. Basically a process of converting a given input key into output value. What is hash table is also clear. You can clearly see what is a hash table doing. It is mapping the key with the index location where the value is stored, and each key has a unique index location in this hash table, right? But coming to the question again, why do we need it? And coming to this small part where we talk about the time complexity and we say it is efficient, let's take an example and try to understand it, because only when we see an example in working in the practical sense, only then we will understand when a hash table would be more efficient compared to some other data structure like an array. Okay, so let's do that. Okay, so here's an example of hash table versus regular array when we're talking about storing and accessing data. Okay, so here's a question. Store these 8 elements in an array and hash table. Alright, let's look at this data. Okay, let's make an array quickly. Okay, so as you can see on the screen, I have created an array. Let's name it ARR. It's of size 8, correct? And it's gonna store all these values. So when you take the first value, it will store it at the very first location. Okay, now let's say you want to store 5. So you'll come first at the 0 location, you'll see, okay, it's already occupied. Then you'll hop on to the next location, you'll see it's empty. So you'll insert 5. Okay, so obviously when you are traversing through the array, each hop is gonna take some time, correct? So let's say that the time taken to access one memory location is 1 second. Okay, so this is just something that we are assuming. Okay, this is not exactly 1 second when you're accessing a memory. Let's assume that it is taking 1 second to access a particular memory location. So when you are filling out this array linearly, you'll keep on hopping till you find the next empty location. So when you want to insert 7, you'll go to first location, you'll find that it is already full. Then you'll do one hop. So you've taken 1 second, correct? So you'll find out that the second location is also full. You'll take one more hop. So you'll take 1 more second over here. And now over here it's empty. So you'll enter 84. Similarly, when you keep on inserting values, you can see that it is gonna take 1 second extra every time, because you'll start from 0 location and then you'll keep on moving ahead, right? Unless of course there is a way to keep a track of the free index position. You can do that programmatically, but if you just have this array plain and simple, and when you are inserting values, every time you insert a value, you are gonna take 1 more second extra to hop to the next empty location, correct? So basically when you are to insert the last value 2 in the last index position 7, how many seconds have you taken? 1, 2, 3, 4, 5, 6, 7 seconds were needed to insert the number 2 in the last position. So that's the worst time, right? That is the worst time for insertion. Now let's take this same example and let's try to insert these same values inside a hash table. Okay, so for that, of course, the keys are 1, 5, 7, 84, 32, 6, 3 and 2. Okay, so since right now we know the number of elements are 8, let's create a hash table over here with 8 indexes. Okay, so let's create a hash table. So this is the index 0, 1, 2, 3, 4, 5, 6 and 7. Okay, and these are the keys basically which we are supposed to store inside this hash table, correct? So the only one component now left is basically the hash function. So let's define a hash function, and let's say the hash function is going to be a function which takes the key and calculates a modulo 8. Okay, so hash function is nothing but going to calculate key mod 8. So key modulo 8. This is going to be our hash function. So what is this hash function? So this is a mathematical expression. You take this key, if this is 1, you do 1 mod 8. When you are taking a modulus, we calculate the remainder, right? So 1 mod 8, you're gonna get 1. So the output is basically what? This output generated by the hash function is going to be the index position where this key is to be stored, correct? So the reason why I took 8 over here is because we have only 8 spaces or 8 data locations or 8 indexes basically where you can store these numbers, and we don't want to store them in the same place, which happens when collision happens. I'll explain that case also in a minute, but right now that is the reason why I took this 8. You don't have to put your focus on why I took this function. This function can be anything, but right now let's calculate this for 1. So when you pass this 1 inside this hash function, what do you calculate? 1 modulo 8. What do you get? You get 1. What is this 1? 1 is nothing but the index position which is over here. This is where you will store this 1. Correct? So 1 will be stored over here. Let's calculate another one. Let's say now you want to calculate for 5. So you send this 5 inside this hash function. So key modulo 8. So 5 modulo 8. What do you get? You get 5 only. Correct? Because it's not directly divisible. You are taking the remainder. So if you take 5 mod 8, you're gonna get 5 as the output. I hope you know how to take this mod function or mod calculation. So 5 is nothing but the index 5. Correct? So this function will redirect to this index location where this key is going to be stored. So let's store 5 over here. So now let's take a look at 7. So 7 modulo 8 is gonna be equal to 7 itself. So 7 is gonna be redirected over here at index position 7. So this key is gonna be stored directly over here. Let's take a look at 84. So when 84 is sent to this hash function, you're gonna see 84 modulo 8. What is 84 modulo 8? It is gonna give us 4. So 4 is index position over here. So that's where 84 is gonna be stored. Let's calculate for 32. 32 is exactly divisible by 8. So 32 mod 8 is gonna give you 0. Correct? Because it is exactly divisible by 8. So 0 is index position this. So 32 is gonna be stored over here. Let's take a look at 6. So when you send 6 into this modulo function, 6 mod 8 is gonna give you 6 itself. So we are gonna store 6 over here. Similarly, 3 is gonna be sent into this mod function and 2 is gonna be sent. So 3 mod 8 obviously is gonna be 3 itself. So 3 modulo 8 is obviously 3. So 3 will be stored over here. And 2 modulo 8 is again gonna give you 2 mod 8 is obviously gonna give you 2 itself. So 2 is also gonna be stored at index position 2. Correct? Makes sense? Alright. So now you can see our hash function, which is key mod 8, applied on all these key values gave us index positions where these keys are to be stored. Correct? So 1 got stored at index position 1. 5 got stored at index position 5. 7 got stored at index position 7. 84 got stored at index position 4. Correct? Now let's say this calculation takes 2 seconds. Okay? So every time you want to store a particular key, let's say you wanted to store 1, you send this into this hash function. Correct? It took 2 seconds to determine the index position. So when you send 1, you got 1 mod 8, which is equal to 1 itself. This whole process of finding the index position took 2 seconds, and then you store the value at this index position 1. Correct? Similarly, when you are storing 5, again you send 5 into this hash function. You said 5 mod 8, which is equal to 5. How many seconds will this take? This will also take 2 seconds. So in 2 seconds, again, you found index position 5 where you stored 5. So you can see that all these individual keys took 2 seconds to be stored inside this hash table, because every time the same operation was calculated, and since we've assumed that it is taking 2 seconds, you can say that every time you want to store a particular key in the hash table, it is taking constant time. In this case, the constant time is 2 seconds. Now coming to the array, if you observe, as the size of the array goes on increasing, the seconds taken to store particular value was also increasing. So when you are storing the very first value, it must have taken less than a second. But when you are storing the second value, you have to hop from index position 0 to index position 1. That took 1 second. When you are storing the next value, it was taking 2 seconds. Which means that the storing of data in an array takes O of n as time complexity. Correct? So the time complexity for storing data in an array is O of n. And n corresponds to the size of the array. So let's say the size of the array is 7 and you want to insert the value at the last location. You will start from 0, 1, 2, 3, 4, because you'll check now whether it is empty or not. Only then you can insert the value over there. So as the array size increases, the seconds taken to access the last position or to access the lower or ending positions goes on increasing. Whereas if you come to the hash table, the calculation of indexes always takes 2 seconds, and as soon as you calculate the index position, you simply have to store it at that position. So it is always gonna take 2 seconds or whatever seconds it takes to access a particular memory location, which means that it is constant time. Okay? Alright, so this was time complexity for storing data. Similarly, let's say you want to access a particular key inside the array. Basically what I'm saying is you want to find a particular key inside the array. Again, the time complexity is gonna be O of n. Why? Because obviously you'll have to search through the array, right? And even if the array is a sorted array and let's say you are applying binary search, even then the best case scenario it's gonna be O of log n, correct? Now we've studied this time complexity topics, time and space complexity in 2 separate videos in this DSA playlist. Please make sure you watch those videos. Those are absolutely important topics in data structures and algorithms. Those concepts need to be cleared out thoroughly. So I have made a dedicated video. You guys can check it out. So coming back to this example, let's say you want to search key equals to 6. Okay. You want to search 6 in this array. So in an array which is not a sorted array, you'll start from index position 0. You'll check the value. Is it 6? No. Then you'll hop to the next one. Is it 6? No. Then you'll hop to the next one. And you'll keep going linearly till you find the value which is matching to what the key you are searching for. This is nothing but a linear search. So imagine how many seconds did you waste to access individual memory locations. You check the first one, you didn't get it. Then you hop to the next one. So 1 second wasted over here. 1 second wasted over here, 1 second wasted over here, 1 second wasted over here, and 1 second wasted over here. So total 5 seconds were required to access 6. Now coming back to the hash table. Over here, let's say you want to search the key k equals to 6. So what you'll do? You'll pass this 6 in this hash function. The hash function will take the key 6. And what does this hash function do? It will calculate a modulo 8. So 6 modulo 8. Which will give you 6. What did you get? You got the index position in the hash table. You'll go directly to the index position 6 where the value is stored. How much time did this take? Again, constant time 2 seconds, because this calculation we've assumed takes 2 seconds. So no matter whichever value you're searching for, let's say you're searching for value 7. So you'll simply replace 7 modulo 8. You'll get index position 7 and you'll directly jump to index position 7. You will not start from 0, then go to 1, then go to 2. You will directly calculate the index position using this formula, because this is the hash function currently. It can be anything in different scenarios. Right now for us, this is the function which takes 2 seconds. That is the assumption. And then you'll directly jump to that index position to find your value. So you can see that this is much more efficient. And again, this is constant time. That is why it is O of 1. Okay. So no matter whichever value you are searching, all of these values will be searched or will be accessed in this hash table in the same amount of time. But in the array, when you're doing a linear search, the value which is towards the end of the array will take more time compared to the value which is at the start of the array, right? So this is where the difference comes between an array data structure and a hash table data structure. And this is just an example. This is not necessarily always true, because as the number of values increase, the efficiency takes a hit even in the hash table cases. And another problem that hash table generally suffers is called collision. Just to give you an example, let's just say instead of this 2, let's just say you were to store a value called 8. Okay, you wanted to store 8. So what you'll do, you'll send 8 into this hash function. You'll say 8 modulo 8, which will give you 0. So 0 is nothing but the index position. But when you jump to this index position right now, you can see you already have 32 stored at index position 0. So this case is called collision, which means that 32 and 8 both are wanting to be stored at the same index position. Correct? Even 32 is going over here and even 8 is going over here when you calculate the mod with 8. So basically this hash function is not a very perfect hash function because it is creating collisions. Collisions are nothing but when the hash value is calculated for 2 of the keys end up at the same index. For multiple keys, if you are getting the same index, that is called a collision use case. And when that happens, this creates complexity because we are already stored 32. Where will we store this 8 now? Correct? So this is a issue that happens in a hash function. So hash function should be written in such a way that every time you pass a key, only a unique index is generated in the hash table. And that is not possible every time, because when you're dealing with thousands and thousands of records, thousands and thousands of data to be stored, there will be cases where same indexes will be generated even though your hash function is as complicated as possible, right? So there are techniques to deal with collision as well, which adds on to the complexity. We will talk about that in further videos, because collision management is also important when it comes to hashing. But this was just an example to tell you guys that hash table is not always the perfect data structure to be used every time. Okay. Alright, so this was an overview about hashing. So basically we understood what is hashing. We also understood the bigger important question that why do we need hashing? We took an example of how a hash table is more efficient compared to array in this use case. So that also gave us an understanding of what is a hash function as well as what is a hash table. Okay. Okay, so I'm gonna wrap up this video over here. I hope all these introductory concepts of hashing, why do we need it, what is a hash table, what is a hash function, and how it is better compared to some other data structures is much more clear now. If you have any queries, please let me know in the comments below. If you like this video, definitely comment on this video. Do give it a thumbs up. Do share it with your friends. Take down the notes, take down the theory, take a screenshot if you are using it to create notes. You can create your digital notes by taking screenshot of these different points that I've mentioned over here. You can also note down this diagram. And that's it for this video, guys. I'm gonna wrap up this video over here. Thanks for watching. See you in the next one. Peace.